So, assuming that I'm going to go with the 1/8" version, I'm going to delete this operation. You can just select it, hit delete, and like everything at this point, it'll take a little while to refresh and update, and just let it do its thing, and it looks good. So maybe one final simulation just to make sure that everything looks okay. Looks like we have what we need. Great. You'll also notice that things move really slowly when you're in the simulation perspective. So if you go back into create, now we're just dealing with the surface and not the calculated stock, which definitely helps things. So once you have everything set, you could take a look at the information globally for the whole thing, and this will show you each operation line by line. So it'll show you the feed rate that you have set. Unfortunately, it doesn't show you the spindle speed, but I don't think there's a way to show that either. But it does show you in total the machine time that it'll take. Keep in mind these are best case scenario numbers, so typically this doesn't account for acceleration and deceleration in the machine, and so I would probably add at least 25% to this time. So this would probably take anywhere from 3 to 4 hours to machine in the end. So as far as creating the G code for this, if you go to the DC Labs website, dclabs.wikispaces.asu, and you go under RhinoCAM resources, there is a file right here which you can download and place on the computer that you're using under the following address right here. And once you've done that, you will find that option when you go to post your G code. Now there's a couple different ways that you can create the G code. In theory, you can just select the MOP, the machining operation set, and right click and then hit post. The problem with that is that it's going to create G code that includes all three of these, and there's no gap in between them. There's no pause because our machine doesn't recognize a pause. So that's not going to work because we need to have a tool change in between this and this. So really what you need to do is export each one of these individually. So I'm going to post, and maybe I'll just post it in here. I'm going to maybe give this the name of whatever operation I'm doing. So horizontal, rough. Usually what I do at this point, I know how many operations I have, so I'll actually specify that in the name, so 1 of 3, and I might also type in the size of the tool, in this case 25 flat. Now as far as the post, you can see that there's literally probably a couple hundred posts that we can choose from. You should find the one that says DC Labs that you've downloaded and installed, and you hit post, and that will create the post for you, and it opens up in Notepad, and that's literally what the post looks like. This is what the G code looks like. So this is where it's telling the controller things like the spindle speed, for instance, 12,000 RPM. If you look for, let's see here, F, right here is your feed, and you'll see that there's different F's throughout the code as it's doing its different movements. These are all just movements that it's doing. So as you cycle through here, you can see that in some cases you have an X and a Y on the same line. In other cases you just have an X when it's maybe just moving in one direction from one point to another. But that's basically it. So you'll post all the operations you have separately, and then just sort of keep them together, and you'll be able to feed them to the CNC machine that way. Thanks a lot for watching.